Hey guys, it's Brandon, and in this video I'm going to show you how to do problem number 32 from chapter 11. So first, read the problem, which says, a student sits on a freely rotating stool holding two dumbbells, each of mass 3.00 kilograms. When the student's arms are extended horizontally, dumbbells are 1.00 meters from the axis of rotation, and the student rotates with an angular speed of 0.750 radians per second. The moment of inertia of the student plus stool is 3.00 kilograms times meters squared and is assumed to be constant. The student pulls the dumbbells inwardly horizontally to a position 0.300 meters from the rotation axis. So in part A, find the new angular speed of the student, and part B, find the kinetic energy of the rotating system before and after he pulls the dumbbells inward. So first, I drew the picture again. And in the before picture, you have your student on the stool, and he's traveling at an angular velocity of omega initial, holding his two dumbbells of mass m, each of mass m, and they are both a distance d1 from the rotation axis. In the after picture, he's traveling at an angular velocity of omega final, and he's holding the dumbbells mass m still, except now they're each a distance d2 from the rotation axis. And on the side there you can see mass is equal to 3.00 kilograms, initial angular velocity 0.750 radians per second, d1 is equal to 1.00 meters, d2 is equal to 0.300 meters, and initial moment of inertia of the student plus the stool is 3.00 kilograms times meters squared. So, in part A, you're solving for the final angular velocity. So first you write your conservation of angular momentum, which is L initial equals L final. And next, you can rewrite that as the initial moment of inertia times the initial angular velocity is equal to the final moment of inertia times the final angular velocity. And since you're solving for your final angular velocity, you can rewrite that as final angular velocity is equal to initial moment of inertia times initial angular velocity divided by final moment of inertia. And for your initial moment of inertia, you have the inertia of the student plus the stool, which is 3.00 kilograms times meters squared. And then, due to the parallel axis theorem, you have to add the inertia of the two dumbbells. And from the parallel axis theorem, you get that the moment of inertia of the two dumbbells is equal to 2md1 squared. And you multiply that by your your initial angular speed, and divide that all by the final moment of inertia. And the final moment of inertia, like the initial moment of inertia, is 3.00 kilograms times meters squared, plus, due to the parallel axis theorem, 2 times the mass of the dumbbells, this time a distance d2 squared. So, you plug in your numbers, and hopefully you get 1.91 radians per second. Now, in part B, you're solving for the initial and final kinetic energy of the system. So the initial kinetic energy of the system is equal to 1/2 times the initial moment of inertia times the initial angular velocity squared. So you plug in your numbers again, and hopefully you get 2.53 joules. Finally, you're solving for your final kinetic energy. So that is equal to 1/2 times the final moment of inertia times the final angular velocity squared. Plug in your numbers again, and hopefully you get 6.46 joules. There you go.